Okay, hello guys. So we're starting again. Wait, let me open the academy. So I'm a bit lazy today, so I will just pick. So I picked the A room with one of the lesser rooms. Pick a path with the lesser rooms. So I picked Clickjacking. It has like 19 rooms, so I'm actually a bit lazy today, but yeah, I made myself study. Okay, let me drink first. Okay, let's start. Let me open up my notes and set up the notes. So today we are going to learn about clickjacking. So this is actually my first time studying about clickjacking, so I know nothing about this. Like I know a little bit, like I know the basics of clickjacking, like I know the clickjacking and forensics, but I didn't know it was a phone-in website, so let's read. What is clickjacking? Clickjacking is an interface-based attack in which a user is tricked into clicking an actionable content on a hidden website by clicking on some other content in a decoy website. What? Consider the following example. A web user accesses a decoy website. Perhaps it is a link provided by an email. Also, it's like phishing, right? Phishing. And clicks on a button to win a prize. Unknowingly, they have been deceived by an attacker into pressing an alternative hidden button, and this results in a payment of account on another site. This is an example of clickjacking attack. The technique depends on the incorporation of an invisible actionable web page or multiple pages containing a button or hidden link. Say within an iframe, the iframe is overlaid on top of the user's anticipated decoy web page content. This attack differs from CSRF attacks in that the user is required to perform an action such as a button click, whereas CSRF attacks depends upon forging an entire request without the user's knowledge of input. So it's similar to XSS, right? Am I wrong? From my understanding, this is similar to XSS because some of the XSS you need to click, right? What I mean by that is, imagine so the user has to open a link. Oh, but it's kinda different though, because I think this could also be chained with XSS, but I think this is a little different. So let me save that to my notes. Protection against CSRF attacks is often provided by the use of CSRF token, a session-specific single-use number or nonce. Clickjacking attacks are not mitigated by the CSRF token as target session is established with content loaded from an authenticated website. And with all requests happening on domain, CSRF tokens are placed into requests and passed to the server as part of normally behaved session. The difference compared to a normal user session is that the process occurs within a hidden iframe. So I'll put it on my notes again. How to construct a basic clickjacking attack. Clickjacking uses CSS to create and manipulate layers. The attacker incorporates the target website with as an iframe layer overlaid on a decoy website. As an example, using the style tag and parameters is as follows. So what's the difference between this and CSRF? The target website iframe is positioned within the browser so that there is a precise overlap of the target action with the decoy website. Using appropriate width and height position values, absolute and relative position values are used to ensure that the website accurately overlaps the decoy regardless of the screen size. Browser tab and platform. The Z-index determines the stacking order of the iframe and website layers. The opacity value is defined as 0 or close to 0 so that the iframe content is transparent to the user. Browser clickjacking protection might apply threshold-based iframe transparency detection. For example, Chrome version 76 includes this behavior but Firefox does not. The attacker selects opacity value so that the desired effect is achieved without triggering protection behavior. So the goal is for the user to click right. I think what this means is that they are creating a dummy website which has a button and an iframe. So the iframe will be close to invisible, so see, the opacity will be reduced to almost invisible, so it's transparent to the user, so the user doesn't know that there's an iframe. Basic clickjacking with CSRF token protection. This lab contains logic functionality and delete account button that is protected by CSRF token. A user will click on elements that display the word click on a decoy website. To solve the lab, craft some HTML that frames the account page and force the user into deleting their account. Oh, so this is so hard actually. Do we need a VPS for this? So let's check again. So I don't feel like I understand this yet, so I think I'm just gonna follow the solution. Or maybe I'll just find it online. So I have no idea on how to solve this, so let's try viewing the solution. Oh, we can view the exploit actually. Or that doesn't work. Why is it not working? Oh, okay, I understand. Oh, I understand this now. So, oh, okay. So we can actually create the opacity to 0.1, then configure the exploit again. No, we should make it lower. Let's make the top 500. Almost, we're close. What about 570? Okay, not even close. Let's make it 700 then. Oh, it's nice. 700, maybe 120. Too low. 510. Then make this click. So the user will click, right? So I have to make that click. Yeah, nice. Then we can create the opacity, we can lower the opacity, then view exploit again. Nice. Then let's deliver. Nice. Okay, I understand clickjacking now. So this is very interesting. I didn't know iframe could load the website. So what? Oh, this is so fun. Oh, so that's what iframe is used for. I always thought because I only use iframe XSS, right? I always thought iframes just like loads the XSS, but I didn't know it would load a website. So it's a bit interesting for me. This is so fun. Wait, did I solve it though? Oh yeah, I solved it. Well, that took a long time. Okay. Wait, let me put this in my example. Oh, that was so fun. I didn't know clickjacking was this cool. Okay, so now click bandit. Although you can manually create clickjacking proof of concept as described above, this can be fairly tedious and time consuming in practice. When you're testing for clickjacking in the wild, recommend using Burpsuit's Click Bandit tool instead. Ooh. This lets you use your browser to perform the desired actions on the frameable page, then create a HTML file containing a suitable clickjacking overlay. You can use this to generate an interactive proof of concept in a matter of seconds without having to write a single HTML or CSS. So let's view the Click Bandit tool to respect the portswigger. Let's see. Interesting. I'll take a look at that later. Let me put this in my notes so I know. Okay. Clickjacking with pre-filled form input. Some websites that require form completion and submission permit pre-population of form inputs using get parameters prior to submission. Other websites might require text before form submission, as get values form part of the URL, then the target URL can be modified to incorporate values of the attacker choosing, and the transparent submit button is overlaid on the decoy side as in the basic clickjacking example. Oh, so I think what this means is that we can get the form page. Clickjacking, we form input data per field from a URL parameter. This lab extends the basic clickjacking example in the lab. Basic clickjacking with CSRF token protection. The goal of the lab is to change the email address of the user by repopulating a form using a URL parameter and enticing the user to inadvertently click on an update email button. To solve the lab, craft some HTML that frames the account and fools the user of their email address by clicking on click me decoy. Okay, let's try. Sounds interesting, to be honest. While waiting for it to load. Okay, nice. Let's continue. I hate how it's so laggy. The exploit server is so fast, but the challenge is very laggy for me. I think it's because of my slow internet, but I don't know. Ah. What if? But how do we change the email though? Like they can press the update email, but how can I make them? Okay, so I actually need the solution. Wait, what? So we can use that? Let me open Burpsit to find. So I need to find the parameter where it's asking for the email. I don't know. Let me try using burp. Maybe I can find that so it doesn't feel like I'm cheating. Oh, wrong email. So let's put the one that we did before, but this time we can use this one. Through the exploit first, but no, this time I want to view the opacity. Huh? Oh, it's a bit off, probably 500. No, for 400, 490. Oh yeah, no, it's on the click email. So I just need to find the parameter where the goal is to find a parameter which is asking for the email change. So let's try intercepting the email. Let's change it to B. How do they find it? I don't understand. Let me check the solution again. I can't email. Does that even work? Oh, because the ID is maybe. Oh yeah, because here's also a parameter. So I feel like this is a bit grassy, but I don't know. I think this is a skill issue from me. So let's try giving it to the let's deliver exploit. Yeah, nice. But how do they know? Is it because of the name or the require or no man, I don't understand shit. Let's just continue then. Frame busting scripts. Clickjacking attacks are possible whenever websites can be framed. Therefore, preventative techniques are based upon restricting the framing capabilities for websites. A common client-side protection enacted through the web browser is to use frame busting or frame breaking scripts. This can be implemented via proprietary browser JavaScript add-ons or extensions such as no scripts. Scripts are often crafted so that they perform some or all of the following behaviors. Check and enforce that the current application window is the main or top window. Make make all frames visible. Prevent clicking on invisible frames. Intercept and flag potential clickjacking attacks to the user. Okay, let me save that. Frame busting techniques are often browser and platform specific, and because of the flexibility of HTML, they can usually be circumvented by attackers. As frame browsers are JavaScript, then the browser's security settings may prevent their operation, or indeed the browser might not even support JavaScript. An effective attacker workaround against frame busters is to use HTML5 iframe sandbox attribute. When this is set, with the allow forms or allow scripts values and the allow top navigation value is omitted, Then the framebuster script can be neutralized as the iframe cannot check whether or not it is the top window. Both 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 of the both the allow forms and allow script values permit specified action within the iframe, but top level navigation is disabled. This inhibits frame-busting behaviors while allowing functionality within the targeted website. Interesting. The sub is protected by a framebuster, which prevents the website from being framed. Can you get around framebuster and conduct a clickjacking attack that changes the user's email address? Changing click me solve. Okay. So let's try again. This should be fun. So let's try using the email again. Will it work? So it doesn't work now. Oh, I forgot that equals. So it works, still works. So let's make it like this, then try updating my email. Yeah, so it still works. So let's try make it B now. But I don't think the ones we did before will still work. Let's try. Fail. This should still work. Yeah. Let's try the good old iframe src, frame src. Fail. What happens if it's so laggy? We remove this. This page cannot be framed. Oh, interesting. So I think this is the same. So let's try using the HTML5 bypass and hopefully it works. So let's try. Fail. Does it work? So it actually works. Nice. So we can then put the click a bit higher, maybe 490. Let's view. Higher, 470, and change it to click. Hopefully it lands. Yeah, I want it to be precisely on the button. Yeah, nice. Then let's deliver, and we solve the challenge. So the only difference is the sandbox allow forms. It's the same from what was told earlier. If you see here, see the allow forms. The only difference is this sandbox. Yeah. I love how they found that out, and it's pretty interesting. So okay. Combining clickjacking with DOM accesses attack. So far, we have looked at clickjacking as a self-contained attack. Historically, clickjacking has been used to perform behaviors such as boosting likes on a Facebook page. However, the true potential of clickjacking is revealed when it is used to as a carrier for another attack, such as DOM access attacks. See, I knew it. Accesses could be chained. Implementation of this combined attack is relatively straightforward, assuming the attacker has first identified the XSS exploit. The XSS exploit is then combined with the iframe target URL so that the user clicks on the button or link and consequently executes the DOM XSS attack. This lab contains XSS vulnerability that is triggered by a click, construct a clickjacking attack that fools the user into clicking the click me button to call the print function. So the goal is to call the print function. But where is the print function? So let's try making the iframe. But how do we do the accesses though? Oh, so I can actually put it like that. So we can put the name. Oh, it works. What if? So I think it's using an image SRC on error. Yeah. Print. So let's try continuing. And email equals a and subject equals nothing and message equals a again. Oh, okay, so that's nice. Then let's see. Can we do the click jack? Okay. So I think we need to make the height bigger. And we need to lower the, let's double it. Oh, that's too much. 700? No, 800 maybe? I feel like it's closer to 800. Never mind. Oh, I changed the wrong. This to be 800. Wait, what? Why is it broken now? Is it broken or is it lagging? Why is the height only 100, man? Oh, so it's actually very close, but I need to make it a bit higher. Maybe 20. Yeah, that's close enough, but I feel like it's 825. Then we can change it to click me, and then deliver the exploit. Yeah, nice. So I was a bit lazy, I'm sorry. I didn't want to take a long time because like I said from the start that I'm a bit lazy. So I'll just today I'm a bit lazy. Usually I'm not this lazy, but I'm actually a bit tired. Yeah. Multi-step clickjacking. Attacker manipulation of inputs to the target. Okay, let me save. Never mind. I don't think I need to save this. Multi-step clickjacking. Attacker manipulation of inputs to a target website may necessitate multiple actions. For example, an attacker might want to trick a user into buying something from retail websites, so items need to be added to the shopping basket before the order is placed. These actions can be implemented by the attacker using multiple divisions of iframes. Such attacks require considerable precision and care from the attacker perspective if they are to be effective and stealthy. This lab has some count functionality that's and also has confirmation dialog to protect against clickjacking. To solve this lab, construct an attack that fools the user to clicking delete account and the confirmation dialog by clicking click me first and click me next decoy action. Oh, so I need to create 2 clickjackings now. This actually sounds very fun, so let's try. Oh wait. Oh, this is getting so fun. So let me try to set. Okay, so I can actually do that maybe. Cause I'm just a teenage dirt baby. Let's call it first, and this is also first. So let's try this first. Does it work though? What if we give it 200 or 20? Oh, it works. Okay, nice. So that's good. We know that works. So it's called click me first, click me next. Okay. Me first, and also let me copy this part and click me next. This is the second one. Let's get the position. I'll just write it myself. Then we shall take the... I can use tab. Position absolute. Then we can... I'll just copy it. I'm so annoyed. Nice. Let's make it different. So this is the iframe, right? So the goal is, wait, let me open my account first. So the goal is delete account button, then confirmation dialog. Interesting. So let me Peter. So we can create an iframe now, which has the iframe frame, which has the URL fill. Oh wait, the opacity is so low. Let's turn the opacity into 0.3 maybe, so it's much more easier. So let's position the first button first to 600 maybe. 600. Feel. Okay, it's not that far. Maybe 400. Nope. 450. Please say yes. It's so close. 500. Okay. So after they click on that, we need to make it lower. So it's actually very close. Maybe it's 270, and this is maybe 300. Maybe. Oh, it's very, very close. I didn't expect it to be that close. So let's make it 40 then. Click me first, then click me next. So no, so maybe 210. Okay, let's try this one. Deliver exploit. Nice, that was actually very fun. Okay, so we are going to learn about preventing clickjacking attacks. So how do we actually prevent clickjacking attacks? Let's read. We have discussed a commonly encountered browser-side prevention mechanism, namely frame busting scripts. However, we have seen that it is often straightforward for an attacker to circumvent these protections. Consequently, server-driven protocols have been devised that constrain browser iframe usage and mitigate against clickjacking. Okay, clickjacking is a browser-side behavior, and its success or otherwise depends upon browser functionality and conformity to prevailing web standards and best practice. Server-side protection against clickjacking is provided by defining and communicating constraints over the use of components such as iframes. However, implementation of protection depends upon browser compliance and enforcement of these constraints. Two mechanisms for server-side clickjacking protection are extreme options and content security policy. Oh, interesting. Let me save this. No info for me, so I didn't know that extreme options is used to defend against clickjacking. I've heard about extreme options before, but I never use it myself personally. Extreme options. Extreme options was originally introduced as an unofficial response header in Internet Explorer 8. It was rapidly adopted within other browsers. The header provides the website owner with control over the use of iframes or objects, so that inclusion of web page within the frame can be prohibited with the deny directive. Alternatively, framing can be restricted to the same origin as website using same origin directive. Okay. Or to name website using allow from directive. Extreme options is not implemented consistently across browsers. The allow from directive is not supported in Chrome version 76 or Safari 12, for example. However, when properly applied in conjunction with content security policy as part of multi-layer defense strategy, it can provide effective protection against clickjacking attacks. So this is actually very interesting, and let me put that on my notes, because it's very important for me. And next, two more. Content security policy is a detection and prevention mechanism that provides mitigation against attacks such as XSS and clickjacking. CSP is usually implemented in the web browser server as a return header as the form content security policy, where policy is a string of policy directives separated by semicolons. The CSP provides the client-side browser with information about permitted sources of web resources that the browser can apply to the detection and interception of malicious behaviors. But also put that on my notes. Okay, so this is the final rule. We are so close on finishing. Content security policy continued. The recommended clickjacking protection is to incorporate frame ancestors directive in the application's content security policy. The frame ancestors non-directive is similar in behavior to the extreme options deny directive. So this is actually very good then. So the frame ancestor self directive is broadly equivalent to extreme options same origin, so it's similar. The following CSP whitelist frames to the same domain only. Alternatively, framing can be restricted to named sites. Wait, I want to see the extreme options again. So CSP actually, so we don't actually need to use extreme, I think, but maybe we can use both so it's more safer. I don't know. To be effective against clickjacking and XSS, CSPs needs careful development, implementation, and testing, and should be used as part of a multi-layer defense strategy. Interesting. So I'll put that on my notes again. because it looks important. Maybe I can use this as a reference for my pen testing in the future. Interesting. So that's it. We completed the clickjacking. Nice. That was pretty fun. I learned something new. I'm sorry if at the start I used the solutions too much because I didn't know what clickjacking was, so I still haven't. If you rewatch the video after a while, I finally understood what the vulnerability was, and I created the exploit by myself, and not by myself. I mean by understanding the stuff. Then I can create it, like recreate the exploit by myself, then exploit it. So, but in the sum of the parts, the where I click the solution is because I didn't know that the parameters can be used, like the email. I didn't know that there was an email parameter from before. So yeah, that's it. That was a bit fun. So I felt like clickjacking is very interesting because it's similar to phishing, right? But phishing and spear phishing is a very wide. I mean, it's very famous right now because it's one of the most common attacks. So me imagining phishing with clickjacking, like we can combine these two to attack. But yeah, this makes me a bit worried when I click emails and stuff sent by people. I'll probably keep checking the browser the browser tools. But yeah, that's it for today. Thank you for watching. See you guys.